Hello everyone, welcome to DSA for the beginners. Now that we have understand how to create, traverse, insert and delete nodes in our linked list, let's look at some of the most important patterns used in coding interviews. We have couple of patterns in linked list. One is slow pointer. Slow pointer, fast pointer pattern. So let's say we have a linked list 1, 2, 3, 4. So if we have to calculate the midpoint of the linked list, which is this. So ideally what we usually do, so we will count the number of nodes, 1 plus 2 plus. So basically the current will traverse through each element and have count of this and then divided by 2, basically 4 by 2, which is 2. But from this particular pattern, slow pointer and fast pointer, what we can do is one pointer moves one step at a time and the fast pointer moves 2 steps at a time, basically. So 4. Slow and fast will start at the same point. Slow will move to one step ahead and then fast will move to second step, 2 steps ahead. Basically slow equal to slow dot next. So by the time fast reaches end, right, slow will be in the midpoint of the linked list. So how do we write it in our Java programming? So let's see that. Okay, as you can see here in our code, so slow and fast both are initialized to head. So we will check while fast is not equal to null and fast dot next not equal to null. So we will try to move the slow pointer to one step ahead and fast pointer to 2 steps ahead. So by the end, slow will be at the middle of the linked list. So this is one of the easiest and most frequently asked linked list question. So let's see the second pattern, that is to reverse a linked list. So basically what we need to do is we need to change the nodes which is pointing from 1 to 4 to 4 to 1. So this is the given, this is the output. So how are you going to do that? By the looks of it, the reversing of a linked list seems a little bit complicated, but the reversing logic is very simple. Let's see. So what are we taking? 2, 3, 4. So we just have to have 3 pointers. One is previous, one is current, and one is next. So with these 3 pointers, we can reverse the linked list very easily. So let's do a dry run. Okay, 1, 2, 3, 4. So basically, this the first element, right? So this should point to a null. So how are we going to do that? So we'll initialize the previous node to null. Okay, so previous will be pointing to null. So current will be pointing to the first element. So I'll remove this. And then while current is not equal to null, we will loop through all the elements. So what we are doing, okay, so I will just explain the logic first. So next pointer is pointing to the next element. What we basically have to do is, so current dot next should basically point to the previous node, and then current should move to next element. So this is the basic idea of this. So 1, 2, 3, 4. Previous is pointing to null, is a null value. So current is here, next is here. So current dot next, we have to make it point to null. So then previous will be moved to current, current is moved to next. So next iteration. So 1 is pointing to null, 2, 3, and 4. So previous is this, current is this, and the next is pointed to here. So what we have to do is current dot next will be pointing to previous. So this link will be gone. And then again, previous will be moved to current element, current will move to next element. So the same thing. The next iteration. So null 1, 2. This link is already removed. So 3 is here, 4 is here. So previous is here, then current. So next element is this. So again, current dot next will be pointed to here. This link will be gone. Previous is moved here, and then this one here, gone. So basically, at the end of the iteration, so what will happen is 4, 3, 2, and 1. So just change the direction of it, but ideally it will be like this. So if we, yeah. So this is how reversing a linked list. So let's see the code for this particular pattern. Okay. So this is the code to reverse a list. So basically what we are doing, we are pointing the previous to null at the start and then pointing the current to head. So while current is not equal to null, okay. Yeah. So while current is not equal to null, so we will first point our next pointer, which is current dot next. So basically 1, 2, 3, 4. Previous is here, null. So current is here. So the first step here, we are going to point it to next. So current is at the head. So current dot next equal to previous. So this is the, so let's take 1, 2, 3, 4. So this is the first step. So this is the second step. Then previous equal to null. Move the pointer to current. This is the third step. And current equal to next. So this is the fourth step. 4-step process. So by the end of this, previous will be pointing towards the last node. So we are going to return that particular node. So what is the time complexity for this particular pattern? So here we are iterating through all the elements. So it will become O of n. So let's see another pattern for linked list, which is to detect a cycle in a linked list. To detect a cycle in a linked list. Basically, what will have 1, 2, 3, 4. Again, this 4 is pointing to 2. So this what we see, this particular thing, this is called a cyclic linked list. So how does it traverse? So 1, 2, 3, 4. Again, this points to 2, 3, 4. So if you see, so this is kind of a loop. So how do we see if this particular linked list has a loop in it? So again, if you remember, so we had seen a technique called fast pointer and a slow pointer. So the same way we are going to have this particular algorithm. So initially, slow pointer will be both for slow and fast will be pointing here. Slow pointer will move one step, and then fast pointer will move 2 steps. Again, slow will be here, slow will come here, fast will come back to here. So at some point of time, slow and fast will point to one of the nodes. So that is when we can see if the linked list has a loop or not. So let's see how this code look like. Okay, yeah, as we can see here, we have 2 pointers, slow and fast. So here slow is moving 1 step at a time and fast is moving 2 steps at a time. So at some point of time, slow will be coming equal to fast. So that is when we can return it as true and say linked list as a cycle. If none of the nodes are, that means slow and fast is not equal, that means linked list has reached an end and there is no cycle in this particular linked list. Okay. Okay. Today we learned some of the most important linked list interview patterns. One is finding the middle node, reversing the linked list, detecting a cycle. So these patterns appear repeatedly in coding interview questions and maybe competitive programming. So in our next video, we'll see some more examples of maybe stacks, queues, and we'll see some of the LeetCode examples. See you in day 7. Happy coding and keep practicing.